So yesterday we have started Unit 5. Okay, and real-time operating system. This is RTOS. We used to say mainly for any embedded applications, the real-time operating system is needed. Okay, so we have seen some introduction part about RTOS, and we compare mm, desktop with RTO, desktop OS versus RTO, desktop operating system versus real time operating system. So the entire operation is about RTO, how it is managing the task, how it is scheduling, race conditions, priority inversion, ISR, interrupt service routine scheduling, inter-task communication. So how the real-time operating system is concerned to work with all these operations. So I think on 2 days I have gave about what is RTO and what is the difference between these two. I think you can see that RTO operating system, we all know we are all using Windows only. So some other than that, Linux, Ubuntu, Mac OS is there. Android and iOS is the operating system for mobiles. Okay, Android we all know we are all using in our smartphone, and iOS specifically designed for Apple phones. Okay, so we have seen RTO is mainly for time critical. That is, I have given the best example. There, RTO is mainly used in embedded applications. So in embedded application, it is always a time crucial on that. So some of the thing is, if person met with accident, the airbag has to be open automatically, or else we were attacking any missiles, and for that, the time is very very important, and the anti-braking system also we need timing. So time is very very important in RTO. That's why they have given what is RTO, that is the definition for this. So the ability of the operating system to provide a record level of service in a bounded response time. The time is important and foremost conditions for RTO. It has to respond quickly, time critical, and there are hardware RTO software. Hardware, wherever I'm using with the help of hardware control, that is hardware RTO. Mainly, they have given some of the examples. Okay, air traffic, vehicle, and all, nuclear power plant and all. Software, web page. Whenever there is a web page, I told the best example today, the Corona count, we were seeing that web page browser will be automatically updated. So that is software RTO, and you have seen where I have placed my RTO. This diagram is very, very important diagram. This is user, ourselves, and this is hardware, and this is application program. In between that, the RTO plays a roles. So always understand that one application program cannot able to do all the things. So far we have discussed elaborately about all the microcontrollers, which is the Intel is one of the manufacturer for 8051, and we have seen Microchip is the manufacturer for PIC microcontroller, and ARM7 has been developed by some Apple and all. So all these things, all microcontroller, and we have seen some instruction set, whether it is CISC or RISC based, whatever may be. I can use my assembly language programming, or else I can use my C programming. That is my application program. But you all know, definitely. To communicate from one system to another system, we all learn about serial protocol. So the 4 units what we learn now, 3 units about microcontroller, and fourth unit about what are the protocols is very necessary to communicate with each other. That is very very important, because the controlling will not happen in a single place, it has to be done. So why the IoT become popular now, combining all this microcontroller with the serial protocol, the IoT become popular within. We have seen that the development starts from some 2011, and now there is an enormous development till 2020. Day to day life we were seeing, wherever we go, the IoT have placed a much thing, and now the attendance have been replaced by a biometric. It's not in all the concern they have replaced. So the attendance are become very easy to manipulate, not only for the staff or faculties are working there. So they have automized for students also. So in some of the schools, by wearing the ID cards, when they enter into the school, automatically the parent will receive the message. Okay, so that much of development. We all know I'm having my application program, and there is some hardware is there, but I need always a RTO, real time operating system is always needed. It is mainly for embedded applications. So you have to understand, so far we have studied all the four units. There it is purely we can speak in a technical way what we learn, like how I can say now, the first three units about microcontroller. Already you know about microprocessor, so easy you can easily correlate. Accumulator is doing this, um, reset button will do that, clock will generate the clock frequency. So something will be common with some microprocessor. Memory we have, then how to communicate with the ports, all and all we learn. So that will be some correlation already with microprocessor. But when you move on to the fourth unit, it is some different journal we have seen about some protocols. Okay, but the fifth unit is entirely different. It's some completely different. It will whatever you have learned so far, it is not connected with the fifth unit. It's a new unit. Are you clear? So what I am saying, that is all very new to you. So you know about operating system, when we use only we know, but what the operating system is doing, you just remember RTO, what it is doing. That is very, very important. So I think this diagram is very important. So hardware is there, one application program is there. User will connectivity with that. But only thing is RTO is also should be there, wherever I need a control, the operating system where I have embedded my program. That is very, very, very important. And I have told you these are the applications of RTO. It is used in widely all industries now. The RTO plays a special role. Okay, so even that why IoT, and still it is become popular and all. We have seen that the control is become automatic. We need not to see. You have seen they have saying that industrial control system, food processing and all. Now um, every day you have seen in the news, I think so, you have seen some vaccine is produced, but you have seen that the vaccine will be produced now automatically. It will be completely sealed, and it will be measured and packed. Everything is happened. You all know all your electrical drives and control will place there. So if some motor will be there, it will take care of running and packing everything. But there will be an automatic control will be there. Their control system will be there, but the entire processor or a microcontroller will embedded. So you have learned three subjects. All the three subject plays the role on all food processing and industrial control system. Precisely it will do the work very precisely. That's why they were saying RTO has to be used wherever we need a precise. If I want to rotate at some 1000 RPM of that motor, na, it will never go on 1001 or 9999. It will go at 1000 RPM. So that's why everything is become popular. So that's why we have taken a time. So while I'm seeing that vaccination development, injection in some medical processing equipments, there also the electrical will backs there. Okay, so I have given the desktop versus RTO. um, these are the differences there. That is the main differences list out at that. Regular RTO is mainly thing is computing time and all we won't focus, but RTO will focus. We'll switch on your mobile or switch on your laptops, PC, tabs and all. It takes some time, 4 minutes or 3 minutes. It's not a much problem, but RTO is always a time response. And why is wide variety applications. If I take a mobile phone, my Android is there now. All smartphones are except Apple. All manufacturer will use Android OS. So wide variety applications, but RTO is generally some specific application only it will be used. Okay, so I am so there are some RTO is also that, and OS will have a multitasking, but RTO will use only time sharing. It never do some multitasking and all. I'm using for some specific application. It will do. But OS will do all multitasking is available. If I loaded my any new app or any other thing, it will begins to work with that. But once RTO is developed for some suitable application, it is not easy to change the coding and all. And the coding of RTO is stricter compared to standard. I told you that I have designed my RTO for this application. Now it will strictly stick on to that application. That is the thing. So these are the difference between RTO and OS. And these are the three types I told you: software and hardware reality system. Software, I told you, responses from a web server, and hardware, I told you, some braking system, nuclear reactors for flight control system. We all know we are competing with China by our Rafale aircraft and all. So everything is are designed with a particular one, and a firm real-time system. It is something one video frames have been missed some transmissions. Actually, hardware and software are some two important types. Apart from that, the firm. Okay, I think advantage and disadvantage, and you just go through it. Actually, it has some advantage, but they listed out so many disadvantage while comparing with OS. Okay, I think I will upload this PPT in the fifth unit. Okay, I think you can see that already we have discussed in the previous class, and these are some popular open source RTOs. How we are saying that Linux, Windows, Mac OS, Ubuntu, and all we were saying. Similarly, this RTO names, it's somewhat new to you. You never hear about anywhere. That's why I told you you can't correlate with any other subjects, or you can't. It's a very very new, and specifically now only you are learning this unit. So you, while you are speaking about, if you put some of them put your embedded as your favorite subject and all, so the question will be, the thing is that you have can answer well comparing to other subject. So I think it will be ruling our actually the error will be there now. So now the embedded is taking the application. Actually it is developed in olden days, but seeing some applications developing something new, so it is very responsive. And Linux, ECOS, use Linux, free RTOs, RTAA, COS, these are some RTO and where it is used. I told you already the ARM is very popular in embedded applications like in smartwatch, Apple phones and all. So some of the RTOs they will use this. Apart from that, we have Hitachi, Intel, um, Machibo, Motorola. These are other concern have using the RTOs. Okay. The next important topic is kernel. Actually, they have given talks development. We'll see how many students. 61 students are there. Okay. So I enabled. Actually, the time is 8:50. Okay, ma. So okay, kernel. Actually, now only Kishan Zango is coming. Kernel, and you have to understand what is that. We all know, to link my hardware and application program, RTO is used. But what is kernel apart from that? um, a core component. A kernel is nothing but RTO. I'm saying real time operating system. The nerve of the real time operating system is kernel. Are you clear? Kernel is the nothing but nerve system of operating system. How our nerves is needed. How whenever I'm getting stimulated, my hands are moving, and whatever the thing, the nerve plays very important role. The same way, uh, kernel is nothing but a nerve system of operating system and is the center core of the operating system. So what the kernel will do? Okay, it this always took all the input output management, process management and all. And similarly, it is mainly to bridge between the applications and actual data processing done at the hardware level. And one more thing, it is interface the user application and the hardware. I already told, RTO diagram you can understand, it will bridge the hardware as well as your application program. Similarly, kernel also do that, but you have to understand kernel is the central core of operating system. And another important word you can understand well, that is the nerve system of operating system. I think you can glow with this program. This is my application program, and this is my hardware. Okay, CPU, memory, devices, and all. Okay, CPU means what, ma? My microcontroller will connected in the CPU. And you all know some microcontroller have odd mode memory, and some microcontroller have we need some external memory, so that is memory. And depending upon the applications only, my memory size will be decided. Okay, and the devices whatever I'm going to connect. So you all understand, this is my basic structure. So kernel is nothing but it is a linking between hardware and software. Are you clear, ma? So it is a central core of the operating system, and is a, I can tell in another way, it is a nerves of the operating system, where I can bridge my whole hardware component with my applications software. The kernel is used. Mainly, it will do all input output management, process management, and all. Okay. Okay, and another thing they have given RTOs. This is the important diagram about RTO, application software and hardware. So mainly, this is nothing but a kernel provides an abstraction layer that hides from the application software and hardware details of the processor, which the application software shall run. So I told you that RTO will be, we have a different open source RTO is there, and it is used for different applications. So mainly for that, the central component of the operating system, they were saying kernel. So kernel will do all management and all. So how it will do all management, and it will do all communications also. Okay, and it is a mainly to basic interface between the computer and the computer itself and the rest of the operating system. So you all understand, I'm saying CPU means CPU is the some dedicated applications for the particular operation. So dedicated means what, ma? I will use some microcontroller for some specific application. So that's they are saying. And the kernel is responsible for management. I told you, RTO, what is the main constraint and time constraint. Now I'm seeing I'm started my class by 8:30, sharply by 8:30. Now the time is 8:50. Still Jagan is coming and Kishan Sango is coming. So what the people are doing now? They take their own time and they are joining. Okay, so even though they all well known, the time is they have to join by 8:30. So people were joining like this. So they were not concerned to the time constraint, but here the time constraint is very important. And one more thing, management, time management means, I think you are in a final year, you also always needs a time management. Today you have to attend the class, and you have a placement class, and as well as you have to go for to write the listen the class, preparing for seminars. So many tasks will be given, but the task management, whoever doing very well, they will have a very big success in their life. Because we even see are saying some applications and all, they will have three important category. One is time management. See, Deep and Ram is now only coming, and time management. And another one is communication. And another important time management, communication, and the time. Okay, time, responding time, that all should be very you have to be improve well. Are you clear, ma? So the same concept only, the kernel will take, it will do all management, it will do all communication, and it will initiate the RTOs. And it is a central component of the operating system, and it will links the hardware as well as application software. Okay, and I told same figure as I have given, that what are the kernel is doing: device IO, file system, device drivers, networking protocol, debugging facilities, other component, device IO, device input output. So in my microcontroller, I'm connecting some devices. For example, I'm connecting some buzzer, or I'm connecting some GSM module, or else I'm connecting some motors. So all this device input output I have to take care with the kernel. So even though it is a microcontroller, we were writing the program, we were embedding doing the coding and all, but while I'm linking the hardware to software, definitely the RTO plays an important role. That part we didn't touch. That's why I'm putting that much of effort to understand well. We have studied about microcontroller, we have studied about all the serial protocol and coding architecture, everything we have learned. But the kernel is another journal. You have to understand how it is doing all this performance and all. Okay. And file systems. So I told you, whether it may be assembly cells, most of the microcontroller we are using only assembly C programming. Okay. And device driver, I told you yesterday one thing. One vibration sensor is there. If any accident happens, definitely it will alert the microcontroller. But sometimes the output of the vibration sensor is very low. Now I have to go with some amplifier. Okay, so then only it will drive the microcontroller. Or else, when I want to interface any motor with microcontroller, I always need a interfacing IC. I have told you, in stepper motor and all, I can't directly connect with the microcontroller. I need a some interfacing IC. So that is called as a device networking protocol. So see, the fourth unit is networking protocol. So what are the protocol you can use? Can you understand or not? RS-232, RS-485, olden days they were used, but now most of the thing is replaced by Ethernet. Even though Ethernet can be used with some distance, but when the distance get increases, the slow, that is the speed of the system is also get reduced. Within the instrument now, I square C, SPI and all I will use. So that is networking protocols. And one more popular networking protocol is USB. Okay. And debugging facilities, you always understand, any error is there, I need always debugging. I think while I'm told about microcontroller, we have that is in PIC microcontroller and ARM7 microcontroller. I told you that J tag is there, and online debugger will be there. That will all have a debugging facility which is available inside the microcontroller. Then other component, coordinating all this, I need a one important operating system, that is the center core of the operating system is kernel. Okay. And you all understand, um, uh, kernel connects the application software to the hardware of your computer. I told you that. And with the aid of some firmware and device drivers, kernel provides the basic level of control over all computer hardware types. It manages the memory access of program. I told you, it's do all. Without kernel we can't do anything. It will do device input output control, file control, device driver control, network protocol control, and debugging facility control, or other component like memory management, task scheduling, all the thing my kernel will do all my work. Okay. And you have seen some responsibilities of kernel, they have listed out in that. Central processing unit, you all know what is central processing unit, mom? My microcontroller is my central. So kernel take the responsibility of deciding at any time of um, many running programs should be allocated to the processor, when to run, and everything will be decided by the kernel. So once I am starting my car, I told you several times, automatically it will indicate something. You have to put your seat belt, and whether your all your power windows get closed, and if handbrake is on, you have to release the handbrake. All instructions are there. So automatically the central processing unit also comes under the control of kernel. And random access memory, I told you that memory is very very important. We all following some Harvard architecture and all. So we have a separate data memory and um, program memory is there. So to access that, how memory, how we can allocate the memory and all, whether the on chip or external memory, all will be decided by that input output devices. I told you that input output. So one simple example, what is input device now? When switch is there, if I turn on, that led has to glow on. So input is my switch, output is my led. Okay, this is another way. I told you vibration sensor is there, then automatically the GPS will send the details to the mobile. So vibration sensor your input. Whenever vibration sensor exceeds the limit, automatically the particular vehicle met with an accident, then it will send the location to the user, that is user mobile phone and all, that is through GPS and GSM module. So that is input output devices management. Memory management, that is very very important, because OS and all, we always have a, memory we don't have, every time when I'm loading my OS, it will denote in my computer this drives this much of memory, or sometime the memory exceeds the thing, then it asks you to delete and all. But here the memory is a very very important one, because the coding, my data, everything will be in a memory. So that is also controlled using kernel. And device management, I told you that is the device management is very very important. Okay, so which device has to be on, and user are detected actually while in running time. It's just like a plug and play, so many devices are there. If I'm connecting and removing, it has to identify the device well, and at the same time, under the RTO, it has a management managing the devices. Still students were coming, they forgot the timer. Okay, then futures provided by kernel, you all understand that, scheduling the process, inter process communications, synchronization, context switching, like full way or full duplex or half duplex communication, manipulation of process and control, interrupt handling, process creation and destruction, process suspension and resumption. You all understand that all these futures will be carried out by kernel. And they have given how kernel will be there: hardware, firmware, assembler, kernel, os is my RTOs, and applications. So you all know hardware component. Firmware is nothing but a software program permanently etched into your hardware. Like whenever I connect my keyboard, automatically what it will do, it will detect this are the key. When I press that key, automatically ask according to ASCII A is pressed down, it will display the A. So that is nothing but a it's a software program, but permanently etched into the hardware. Are you clear? It will identify easily. Assembler, we all know, um, we have a interpreter and assembler. Assembler will translate the assembly level program into machine level program. So you all know all my RTOs are equipped with assembler only, because whatever we are learning, it all low level language only, because it's a assembly language programming. Then kernel, you all know the heart of the operating system, OS and applications. So this is the way how the kernel will be used. So generally we have drawn two diagram: hardware, software. In between the kernel is there, but hardware is there, firmware is there, assembler is there, kernel is there, then OS and applications. Types of kernels we will see. Okay, and these are the types: monolithic, monolithic kernels, micro kernels, hybrid kernels, nano kernels, and exokernels. These are the different types. Okay, so in kernel, how they were dividing and all now. Monolithic kernel, I told you, linking hardware and our software, kernel will be used. But while I'm saying my hardware and software, what are the kernel space? What are the monolithic kernel? What it will do? It will do all file management, inter-process communication, IO and device management, fundamental process management. So you also monolithic kernel will take care of all these things. So all these things means it will do all the file operations, inter-process communication, input and output device management, and process management. All will be taken by the monolithic kernel. So whenever main kernel will be there, so among that you have a different types, more micro, mini, and sorry, micro, mono, hybrid, nano, and exo kernel will be available. Okay, now microkernel, I told you that these are my user space. You have seen all my file system, processor, and all will comes under the microkernel user space. So what microkernel means? The size of the kernel get reduced. So microkernel means only provide the basic functionality, basic functionality of the execution of the server, separate the program. Okay, the device driver, GUI server, and all it will take. So the remaining and all will be taken by from the user space. So microkernel means it will provides only with the basic functionality. It's not like a monolithic kernel. All the response will not be taken by the kernel. So you all understand, depending on application to application, whether we have to install the monolithic kernel or microkernel or known nano kernel and all, we have to decide it depending on the applications. Okay, and next one is hybrid kernel. So hybrid kernel, I told you, it's nothing but a combination of both monolithic kernel and microkernel, and mainly for the safety level they will fix this hybrid kernel. So you have seen that inside the kernel only they will keep the server. Okay, so it will actually, the thing you have to understand that some services such network, stack, or file system in the kernel to reduce the performance overhead of the traditional microcontroller, but still running kernel code such as a device driver as server in user space. You have seen that microkernel, it will take all operations. So due to this all this operation, what happen now? It will running out of time. So too far that mainly it will takes the space like that. Server it will take. Actually, when you see that in monolithic microkernel, the server is also given by the user space. But when you take this hybrid kernel, it will take the server space also. Okay, so that is, I think, people kindly look up this diagram. I have drawn, I have taken the picture of all the microkernel in a single slide. I think you can easily see, segregate what is monolithic, what is micro, and what is hybrid. You all know between hardware and software the kernel will be used. So how long the kernel will take care of the modes, and what are the thing it is allocated for user mode and all. So you all see monolithic, all operations will be in kernel mode. But when you see with that, some of the operation they have given for user mode, and for hybrid it's combining. So here you see that here all like that file system, memory management, device drivers, everything will be in the kernel mode. But when you go for micro, what happened now? It never takes all these things. It all given for user mode purpose, and only virtual programming, and you all see inter-process communication. That alone, IPC alone, it will take. Okay, scheduling only it will take. The remaining all it will go to user. Moon hybrid kernel na, it will take some file and Unix server to user mode, and the application IC, device driver, some basic communication management, memory management, and scheduling will comes under hybrid. I think you all look up this figure, you can understand that monolithic kernel will take all the operation, and microkernel will take only the communication and scheduling and memory management. Hybrid kernel will take combination of monolithic and microkernel. But only thing is, in user mode for hybrid is only the file serving as well as the Unix. I think you can understand the figure well. Am I correct or not, ma? Have you all understand this figure? No response. Are you there, people? Have you understand this figure, ma? Have
Yes,
you?
ma'am.
Who is saying yes, ma'am? Who is saying, ma? Actually, only one student have responded. I won't ask any question. Who have said?
Yes, ma'am. Understood, ma'am.
Yeah. Okay, so you understand, this is my kernel operating system along. I told you that it's somewhat relevant with our, you have in computer science, they have separate paper, operating system is a separate paper, but we are studying that RTO in a one unit, single unit. So whatever the operation is carried out. So first we have seen what is RTO. The next we compare the desktop OS with real-time operating system. Then we have seen what is the RTO and what is the center core of the RTO, which will take care of that. That we have seen one with the word kernel, and we have seen what is kernel and what are the futures of kernel and what are the thing it will do. Okay, I think this is the figure you can understand well what the kernel will do, what are the operation it will do, and all. You all know the kernel will take device. I think apart from this diagram, and I told you the one more diagram is very important diagram. Are you clear, ma'am? This diagram, I think you can able to view this diagram. Device IO, file system, device network, network protocol, debugging other component. And these two diagrams are very important for kernel. Okay. So I think we have seen nano kernel and exo kernel. So nano kernel is nothing but you can understand from the name itself. Nano, na, very, 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 very small. So what it will take now? It will take the interrupt controller or timer uh, to the device driver. So interrupt controller means what you all know, it will handle the interrupt. So what interrupt has to come, it will pay that attention to the interrupt, and then it will activate the system. So that is called as a nano kernel. Okay, exokernel is none, that does not that. It's a theoretical model. Actually it is not uh, well known like otherwise. Mainly exokernel will link a library operating system. Okay. um, uh, to simulate the abstractions of a well-known OS, and it can develop application-specific abstraction for better performance. Actually, while I'm seeing they have told upon the operating system, but when you see, it mainly take over this physical hardware resources, processor time, memory pages, disk block to different program. So it is mainly to allocate the memory space for the different program. So nano and exokernel, we can't compare with monolithic microkernel and hybrid kernel. It is different. Nano, no, only thing is it is mainly handle the interrupt or timer with drivers. Exokernel is nothing but it will allocate the space for the different program. It's like hardware, processor time, memory management, and all. Okay, and you have seen basic functions of RTO. This is the next part of the unit, I can say. So far, we have seen about RTO, we have seen about difference in RTO, we have seen about what is the central core of the RTO kernel, and the base, and we have seen all the things. You have seen your fifth unit. This is your fifth unit, ma. uh, Actually I gave an introduction about, then we have seen the different, and we have discussed about RTO kernel. Even though it is not given in a syllabus, you are supposed to know about kernel, because kernel, without kernel you can't able to define what is RTO. So they have seen that RTO will differ from application to application depending upon the kernel type: micro, mono, hybrid, nano, exokernel. Okay, the next one are the important work of RTO are task management, task scheduling, race conditions, priority inversion. Okay, so you just go over this. Um these are my operations: task management, okay, task synchronization, task scheduling, interrupt handling, memory management, exception handling. If you see all the topic, our unit is get over. Are you clear, ma? So you can understand the flow of the unit. Very important thing is the flow of the unit is very important. So far we have seen all about what is happening in RTO. What is RTO? I think you never hear about this terminologies while you are learning in microprocessor. So this is the new terminology, and which is all focused with RTOs and all. So you have seen whatever I have given this basic functions of RTOs kernel. Then while finishing that, my entire unit will get over. Okay. So task management only take care of communication, memory allocation, device input output, supervising, and timers. Okay. Task management, I told you, task management you people also need it in your lifelong. You need the task management. Okay, how to manage the life. Very important one is when you're working, or when you're doing a work or a thing, you have to decide what is your goal, where you have to be, and all. So that is, and managing the your personal life with your career and all, that has also should be managed. So task management is nothing but how our human beings do same thing the RTO is also doing. So task management means what? In real time application, the process is called task, which takes execution time and occupies memory. Okay. Okay, task management means what? In real time application, the process is called task. We all know task and process are synonyms. Okay, which takes the execution time and occupies memory. Okay, execution time is very, I told you, don't forget the word are related to RTO. Time bounded, and time management. Time is responding time should be quick. All the technical word which are related to the time. So the task management is nothing but which takes the execution time and occupies the memory. Task management is process of managing the task throughout its life cycle, not a single. How we have to manage our entire life cycle? You all in a final year, so you have to be well known to operate the task. What I have to be there after 4 years or after 5 years, whatever may be, you have to decide and you can able to manage that. That will leads your entire life cycle. Are you clear? So the functions, this already we have discussed. So typical task operation, what are the task operation? Creating and deleting tasks, controlling the task scheduling, obtaining the task information. So these are the typical task operation. What are the process? We have to create and delete, control, and information. That is the thing. So I think you can easily remember creating and deleting the task, controlling the task scheduling, and obtaining the task information. So here, process states. You all understand one important thing is task process states. Okay, I think the task process states I will teach in the next class. It's a new thing, and today, students, all are there, man. One have sent to me.
Yes,
Yes,
ma'am.
ma'am.
Yes. Okay. Today, who are all going to take the seminar? Actually, we have some break because I start by 8:30. I'm still speaking, and you are all get bored. Even though I'm giving some examples and all for your purpose. Actually, this unit, what you learn in the previous unit, something you have to imagine and do, because we can't able to see things. So virtually, you have to think. Okay, this will happen. This, and all you have to virtually think. Okay, actually, one of you have sent me this. Shalini, are you ready, Shalini? Shalini?
Yes, ma'am.
Yes. Okay. And another Pavitra?
Yes.
Pavitra is, yes. Okay. I will share you first Pavitra PPT, ma. Yes.
Okay, ma'am.
Okay. Then next Shalini, you be ready.
Okay, ma'am.
Hmm.
Hi, friends. Now I'm going to talk about the street light that glows and detecting the vehicle movement using microcontroller and IR sensor. It is used with the at Mega 8 microcontroller. It is a one type of microcontroller mainly used for the embedded system. Purpose of industrial automation process. Ma'am, next slide, ma'am. Components at Mega 8 microcontroller. It is a microcontroller, AVR microcontroller. DS1307 IC. It is a RTC. It means a real-time clock. PIR sensor. It is a sensor, LDR, LCD, and LED. Mainly, this topic LED is a main part. Ma'am, next slide, ma'am.
Okay. Is it visible? Okay.
This is a circuit diagram of a street light that glows on detecting vehicle movement. Mainly the microcontroller at Mega 8 microcontroller. It is a 28-pin AVR microcontroller. It is based on RISC architecture, and it is mainly used embedded system. The LCD. The LCD is a time and it is used for a time and light intensity value will be displayed on the LCD. And the RTC means it is a DS1307 real time clock. It is a 8-pin device. The main advantage of the RTC is they have an arrangement of battery which keeps the clock and calendar running even if there is power failure. The working means it is the total work means main used to glow the street light when a vehicle is detected in the peak hours. Generally, the street light in glows on the whole night. They are not required in when there are no traffic on the roads. That time we have safe power. How means vehicle detected means the automatically it is turned on and off. The three LEDs are used in the circuit diagram. Um, the vehicle movement is sensed by the sensor. The PIR sensor is colored in red color. It is connected in the Atmeha 8 microcontroller, and three LEDs are connected in Atmeha 8 microcontroller. The vehicle is detected means the PIR sensor is sensed at that time. The PIR sensor is switched on. The LCD is used for a runtime simulation. The light intensity value will be displayed on the LCD. The simulation at the vehicle is detected. The first minute it will be switched on. So LED is glowing full intensity. After 1 minute, the LED is automatically switched off. The main purpose of the LDR is calculate the light intensity value. Only the light intensity value is less than 100 values, the LED will be glowing. Greater than 100 means the LDR throw the signal to the at Mega 8 microcontroller. That time the LED will not be glowing. The LED clock the light intensity of the environment as they are will be changed according the season in the light intensity. The light intensity value greater than 100 means even though the vehicle is coming, the light will be not detected. The main purpose of the street light glows on vehicle movement is saved the power. The energy can be saved in the uh, street lights, ma'am.
Yeah, very good, ma. Next one.
Next one is the advantage, ma'am.
Yeah, working
The
process.
working process, ma'am.
Yeah, very good. See, everyone said she put some GIF images whenever you can understand well. Yeah, very well, Pavitra.
The car will be enter into the street. That time the PIR sensor is sensed to the vehicle. That time the light will be automatically turned on. After it will be turned off, ma'am. That is the main purpose of the.
Yeah. Actually, I have explained you with big microcontroller. Lakshmi also prepared the same thing. I asked her to prepare some other topic. Okay. Tell me.
As the lights are automatically turned on and turned off means the huge amount of energy can be saved in the roadside. The whole night the light will be turned on only. That time using this at Mega 8 microcontroller means we have to save more amount of power. The enough, ma'am.
Yeah, yeah. Good, Pavitra. Actually, she have created with some animation and all to understand well than this. Okay, very nice, very nice. And you have taken Proteus diagram also. Yeah, good, Pavitra.
Thank you, ma'am.
So, ma'am,
Yeah, Vinoba. What Vinoba?
என்னோட டாபிக்கும் வந்துட்டு அதான் மேம்
ஒன்
டிராஃபிக்.
உன்னோட டாபிக்கும் டிராஃபிக் லைட் தானா?
எஸ்
ஏன் நம்ம
மேம்.
எல்லாருமே டிராஃபிக் லைட்டே பாக்குறோம்?
அவ எடுத்தது எனக்கு தெரியாது மேம். சோ அப்போ நான் வேற எடுக்கட்டுமா இல்ல
வேற
அதுவே
வேற எடு வேற எடு. ஒன்னும் பெரிய கஷ்டம் கிடையாது இது எடுக்கிறது.
ஓகே மேம்.
ஏன்னா அப்போ கொஞ்சம் டிஃப்ரெண்டா நாங்களும் தெரிஞ்சுக்கலாம்ல, அதுக்காக தான்.
ஓகேங்க மேம்.
ஓகே, ஷாலினி. ஷாலினி இஸ் தேர். ஷாலினி.
Ma'am.
யா, நவ் இட்ஸ் யுவர் டாபிக்.
Okay. Good morning.
ஆக்சுவலா பிபிடி கொஞ்சம் டிஃப்ரெண்டா போடுங்க, அது ஈஸியா இருக்கும். யூ கேன் வெல் நோன் டு ப்ரிப்பேர் யுவர் பிபிடிஸ் ஃபார் யுவர் ப்ராஜெக்ட் அண்ட் ஆல். ஓகே, கிவ் எ டாபிக் மா.
I will take about automatic car parking indicating system using 8051 microcontroller. This is the block diagram. We have monitor 4 car parking slots. Red color means not empty and black color means empty slots. So there are 4 sensor: IR sensor, infrared transmitter and infrared receiver, sensor 1, sensor 2, sensor 3 and sensor 4. And similarly indicate these car parking slots. There are 4 LED. This is used in shopping mall, multiplexes, car parking areas. There are 4 parking slots, that is 2 rows, 2 by 2 parking slots. You can see here IR transmitter and IR receiver. A car or any model in came in front of the IR sensor. The signal is given from the IR receiver to the microcontroller. Then microcontroller displayed a respective message on LCD. The slot 1 is full or not. The LCD displayed yes means the slot 1 is full. The slot 1 will be turned on, that is full. The LCD displayed no means the slot 1 is turned off, it is empty slot. Similarly, in other car parking area, LED displayed yes means LED will be turned on, it is full. This ways to slot 1, slot 2, slot 3 and slot 4. Next slide, ma'am. We have used in 8051 microcontroller maximum 232 IC. That IC is used to send the data to the computer. Data will be monitored in computer. There are 4 555 IC timer and 4 sensor transformer. The person can see which parking slot is full, so the person can go for another parking area. Thank you.
Yeah, thank you, ma. So she have explained automatic car parking. I think now all our malls, some and all, she have explained well how to park MTR and all, everything it will be desired. Okay, very well, ma. Good, good, Shalini. So today Shalini and Pavitra, where any other students have prepared, ma? Any other students prepared? Ram Kumar. Ram Kumar, where went Ram Kumar? Yesterday he only said, I told you to take the next set. A section ma, I have announced several times. The Deep and Ram, Bharat, uh, very worst ma. So next set, I think today Pavitra and Shalini have taken.
Ma'am, I
Okay.
prepared, ma'am.
You prepared Nilofer. Then you take now.
Ma'am, now only sent in mail, ma'am.
My mail.
Yes, ma'am.
Okay. Okay. Now she will take ma.
Yes, ma'am.
I will share your. So I think tomorrow. Nilofer. Can you
Hello.
able to see ma?
Yes, ma'am.
Yeah, repeat. Mm.
Here we are using components.
Yeah, Nilofer.
Max 232 IC,
Mm.
a microcontroller 8089C5 one of family 8051, GSM modem, capacitor C1, C2, C3, C4, C5 and C6, crystal oscillator, liquid crystal display, potentiometer. The circuit diagram mainly consists of GSM and 8051 family microcontroller. Max 232 IC is connected between RS-232 logic to convert logic levels of GSM to TTL logic levels of microcontroller. Microcontroller Max 232 IC has 16 pins. It is dual driver IC as it has two transmitters and receivers. Transmitter pin T1IN of Max 232 IC is connected to transmitter pin of microcontroller. Receiver pin R1 out of Max 232 IC is connected to receiver pin of microcontroller. T1 out pin of IC is connected to transmitter pin of GSM modem. R1 in pin of IC is connected to receiver pin of GSM modem. 2.1 microfarad capacitors are connected to pins 1, 2, 4, 5 of RS-232. Another 1 microfarad capacitor is grounded from pin 6 of RS-232. GSM modem used here SIM 300 module, 4 pins compatible to TTL logic easily MC as it because GSM modem easily connect to MC as it has max 232. GSM should be connected to supply of 5 voltage. It has SIM slots like mobile. It requires 80 commands for operation. Activation. LCD module connects to port 2 of microcontroller. Data bits D4 to D7 of LCD connected to port 2. LCD used here to display received messages. A button connected to port B of microcontroller is used for sending messages. Applications used in automobile accident detection, control a robot GSM based telemedicine system, ATM theft precaution system. Ma'am,
Yeah, good Nilofer.
ma'am,
Actually, yeah, Nilofer. Yeah, good.
yes, ma'am.
Good Nilofer. Actually, she had taken very important thing is GSM module. So how to connect the GSM module? Okay, and we all know the GSM is a global satellite mobile module where how we were connecting with Max 232 cable. She have explained. So it will mainly for wherever we will connect along with the location also we can able to detect. I think she have most of them will take the GSM is one of the application, but she have concern very about how it is connecting. Okay, ma. I think the next class whether ma'am have joined. Kavita ma'am, students tomorrow Raja Manikam, Sai Mani Teja, and Lakshmi, Sandhya, Santosh, Saranya. Okay, this has to prepare for the seminar, so prepare when come. Yes, Kavita ma'am. Yeah. So you people have understand that where we were using and how we were using. So now a street light replacing is very much very important to serve the energy. Olden days there are so many things. We have a power shortage, and we have an energy crisis problem and all. At that time we don't know how to save the energy, so all the advertisement boards have been replaced, and it should not be illuminated with the lights and all. Everything has become, but now we were saving for the electricity. I think, ma'am, I have to disable. Hey, I have taken the attendance, ma.